right, so dimensional analysis is covered in chapter 3, and it is like the number one method that you're going to be using for solving problems in chemistry. What type of problems? We're looking at, relating quantities to other quantities, or just doing calculations. We're talking about data reduction, etc. Well, the way I think about dimensional analysis is like this. Some people come up with a map. Like in Chem 4, I have heard different maps that people come up with. Go to grams, to this, to this, to this. Step A, do this. Step B, do this. But I don't always have a map, planned out ahead. So, for example, they use this analogy, I think, or whatever, yesterday, and that is, you're trying to reach some destination, and you gotta take some paths through a jungle, and you can't really see the final destination, but you know where you want to get to. And so it's like, which path do you take? There are lots of paths winding through the jungle. Which path do you take? Well, the thing is, some people will just freeze, and they won't take any path. So, for example, when I see or give a dimensional analysis problem and I collect exams, some people have a blank page, and so they didn't even bother trying to take any path. They just froze in place, waiting for somebody maybe to rescue them, but nobody's going to come to rescue, unfortunately. And so the best thing to do is just go on some path. You don't have to have any idea where you're going. Just try something. And what the worst thing that can happen in dimensional analysis is you hit a dead end. If you hit a dead end, it's no big deal. People hit dead ends all the time. So what you do is you just backtrack and try a different path. And so this is the strategy of dimensional analysis. Some people say, well, I don't know where to start or where to go. Well, when problems get kind of tough, you don't. You just kind of try to figure things out as you go along. And so in that last problem we did, there are multiple paths that we could have taken. And so let's take a look and analyze some of those paths. And so we want to go from 100 picometers, and our final destination would be how many inches is that? And so there are different paths that we can take here. And so which one might be the best path to take? And I'll give you back your quiz. This is for yesterday. But if we start off with 100 picometers, I don't know the path, but I need some kind of ratio that relates picometers to something else. And so picometers is going to be equivalent to what? And the ratio is going to be something like, we can have different things. So for example, a pico is 10 to the minus 12. So a picometer would be 10 to the minus 12 meters. So we could just go, 1 times 10 to the minus 12 meters. I have to put the 1 here. Do you know why? 1 times anything is just itself, but why bother putting a 1 there? Why bother putting a 1 there as your calculator? Your calculator is going to want a 1. If you don't put a 1 there, you're going to be off by a factor of 10 in your calculation. So we're going to put in the 1 there. All right, now I have 2 different paths I could take, because I have this path up here. That is, a meter is 39 point. Now, how many sig figs do we want to use in this particular conversion factor? So if we assume this is 3, then I'd want to use 4. But the number of sig figs varies depending on what it is. Is it exactly 100 picometers? If it's exactly 100 picometers, then we won't have infinite sig figs, so we want to use a lot of sig figs. If it's 3 sig figs, then we'd want to use 4. And so if we use 4, that would be 39.37 inches per meter. Right? And so this is one of the paths we could take. An alternate path we could have taken is something like this. We could have done a meter. A meter goes to 100 centimeters. I know that. A lot of people know that there are 100 centimeters in a meter, right? And so, it doesn't matter because which is the right path, which is the wrong path, we don't necessarily know. Okay, but centimeters doesn't take me all the way there, but I know that I can relate centimeters to something else. What can I relate centimeters to? To inches. And so this one we're supposed to have memorized, 2.54 centimeters per inch. But not only do you memorize that one, but you memorize something special about that one. What's special about this one? It's exact, right? And so which path is better? The top path or the bottom path? Why would you say the bottom path? Because on the one hand, the bottom path requires an extra step. And so if it requires an extra step, what makes it worth doing that extra step? Yeah. Okay, you guys have it. It has to do with the uncertainty in it. Because this is an inexact number. This is rounded to 4 sig figs, so we have uncertainty in there. However, is this inexact? Is there uncertainty in this? No, this is exact. No, there's no uncertainty here. This is exact. And so what we do is we'll take 2 steps here that are exact versus this one. This one's going to be subject to round off, error. And so the better path is the lower path here. This is the better path. Because both of these are exact. And this is not. I'll just use it as tilde to represent. That's approximate. And so by rounding that, that's going to introduce some error in our calculation. Now, let's go ahead and do the calculation here. What do you think the number is going to come out? Is the number going to come out big, small? An inch. It should come out very small. About how big is an atom? When we said, if I have a meter stick, how many graduations do I have to divide this, or how many pieces do I have to cut this into? A trillion. That would be about 100 of those, put together. And so a trillionth of a meter stick is extremely small. Well, an inch is a lot smaller. So how big of it should be extremely small. So that's kind of what we expect. So let's just take a look at the calculator here. All right, that came up, but the calculator disappeared. Maybe it's Bing. Sorry. So I'm going to just punch it out on the calculator and just take a look here. So first we take care of the dimensions. So this is the crossing out part. We've got to make sure everything crosses out. And so picometers cancels picometers, meters cancels meters, centimeters cancels centimeters, and that leaves us with the correct dimension, which is inches here. Okay, now we work the numbers. And so just working the numbers, it's going to be 100. Oh, this is not a good calculator. somebody know? We'll try this one. Oh, this one does not have my double E or E key. This one's not good for scientific notation. This 10 to the X key is not the same thing as an EXP key or an E key. When we're doing scientific notation, I don't use this. This is called the anti-log, 10 to the X. And so this scientific calculator is not good for scientific notation. Otherwise, I'd have to input it differently. Should I accept it? It could be, or what? Maybe I should just. Your standard scientific calculators. Let's just try this one. All right, 100. All right, times 1 times 10 to the minus 12. So we have to put in the 1 there because this is how we enter scientific notation. 1, and then the EXPs for scientific notation. And so it's minus 12, so let's go 1, 2, and then change it to a negative. Okay, this is the backwards entry. We have to enter the number followed by the sign. The other one that I had up there earlier, we put in the sign and then the number. All right, then we have times 100. Did we already do this calculation? Divided by 2.4. 2.54 equal. All right, so some people yesterday put in, well, how many sig figs are we allowed? Let's say for this example we have 3 sig figs, you know. It's actually not, it's only 2, but let's say if this were 3 sig figs, this is the way I'd want to show it. I would want to show 4 sig figs in my initial answer. And so I would go 3.937. That would be 4 sig figs. But I'm not allowed 4 sig figs. And so what I do is I round this to 3 sig figs. So I put another equal sign here. I'm rounded to 3.94. And so some people put let's say 9 inches. 3.9 inches, you know, is almost 4 inches. Is that about how big an atom is? No. So an answer like that, you know, 3.9 inches, if somebody puts an answer down at 4 inches, they're not, you know, they're going through the motions, you know, they're plugging in the calculator, but they're not really thinking about the answer. You know, it's not just, the goal is not just to get some number, any number, and write that number down. You know, we got to think about the numbers and if they make sense.
What if it's my calculator? I got 4, 0.0004. So then I win.
Yeah, 4. Then you got to check the settings because your calculator's rounding. Calculators are going to round. You know, how many digits can your calculator carry? How many characters can your calculator carry? There's a certain limit to the number of characters a calculator can carry. Most calculators will carry 8 to 10 digits. If you go beyond 8 to 10 digits, you know what? It's automatically going to round that number. And so let's do a look. I don't know about this online calculator here, but before I do that, let's take a look at this one. This is not the 3.937. It's 3.937 times 10 to the minus 9 inches. 10 to the minus 9, what prefix do we give that? 10 to the minus 9. 10 to the minus 6 would be micro. 10 to the minus 9 would be nano. And so this would be 3.937 nano inches, or 3.937 times 10 to the minus 9 inches. So we could use the metric prefix, although it's English unit, we could use that here as a nano inch. That would be. And so again here, it's 10 to the minus 9. All right, let's see what happens if I plug in, I'm going to plug in 7 nines in here. Okay, it's okay. That's okay. Let's plug in, I'm trying to plug in more 9s. Do you see me clicking there? It's not happening, is it? That's because this calculator only carries 4, 5, 6, 7, 8, 9, 10 digits. This calculator only carries 10 digits. So if you have an 11th digit in there, your calculator is automatically going to round. And your calculator is going to introduce round-off error. What if you need more digits? Well, Excel, Microsoft Excel can carry how many digits? Do you know in a calculation? I think 100 digits Microsoft Excel can carry. Actually, I knew the number, I just forgot it. How many digits can Excel carry? All right, it's somewhere in there. I'm not going to waste time looking for it, but it's a lot of digits Excel can carry. And so, but you need to be aware of that, because when we're working with certain numbers, the calculator could actually give you the wrong answer. Let's say the common thing that happens is this. You know, if this can only carry 10 decimal places, let's say you had something that was 99.99999, that's 5, 6, 7, 8, 9, 10, 11. Let's say you had something like this. Kind of a ridiculous number, but let's say you're supposed to have 11 nines after the decimal. You know what's going to happen in your calculator? Your calculator is not going to call this 99.99. Your calculator is just going to round it to 100%. Is it really 100%? No, it's round off error. It's round off error because of your calculator. And so sometimes we got to be aware of that. But for Chem 4, we don't. For Chem 1A, you don't really. For Chem 1B, you do. You got to worry about it.
Yesterday when we did the calculation, we also got 0.00004. But because we didn't leave it in the scientific notation, so it rounded there.
With your calculator?
Well, we did on the board, so I don't know, like you calculated it.
Oh, okay. You know why? I did that because it's this. This number is a bit ambiguous, because this number can be about 100. You know, how many people were at the park today? Well, about 100, which means anywhere from 50 to 150 people, right? as far as uncertainty goes. Right? That's 1 sig fig. Or you could do, 2 sig figs. If you do 2 sig figs, how many people were at the park? Well, with 2 sig figs of precision, it would be between what? Well, then we go to 3 sig figs, that kind of thing. So this number is a little bit ambiguous because when we have zeros after the decimal, we don't know, is that some estimate to the nearest 100, or is that really measured, and how precisely is it measured? So this could be 1, 2, or 3. Actually, 1, 2, 3, or infinite sig figs. If I put a decimal point here, then automatically that's going to be 3 sig figs. If I see a decimal. If I don't put the decimal, then it's ambiguous. I don't know. If I write in scientific notation, then that gets rid of all the ambiguity. Because if it's 1 sig fig, I just call it 1 times 10 squared. If it's 2 sig figs, 1.0 times 10 squared. If it's 3 sig figs, 1.00 times 10 squared. If it's infinite sig figs, then I just leave it and say exactly 100. And so yesterday when we're doing this, I was talking about 1 sig fig in this. If there's 1 sig fig in this, we can only have 1 sig fig in our answer. And so then we would round it to 4. If there are 2 sig figs, how do we round it? We round it to 3.9. If there are 3 sig figs, we round it to 3.94. That way we carry the, because the sig figs give us an idea of the precision of the uncertainty, we carry it from the given here to the answer. So whatever our uncertainty in the given is here, we have to reflect that in our answer. So that's what I was trying to show yesterday. Since it was a bit ambiguous, I'm just going back and forth from different numbers of sig figs. But once we start doing some problems here, we'll nail it down. Do it. It's just we have to be careful when there are zeros. All right. Let's take a look at some more. So the path is sometimes is tricky to figure out, and sometimes. Sometimes you have to be very careful about the units. And so let's take a look at a couple of challenging problems here. And which one do we want to do first? Let's look at number 75. Sometimes we deal with composite units. Composite would be like composite of 2 different units or something like that. This would be an example here. In the United States, the volume of irrigation water is usually expressed in acre feet. So this is kind of a composite unit because acre is a unit of area. Feet would be height. And so if we have area times height, we get volume. But the area is measured in different units than the height. The area is measured in acres, the height is measured in feet. And so it's two different units. But it's still going to be volume. So if you have an acre of land, if you have an acre of land would be like this chemistry building. Would it be, maybe it'd be close to an acre. Then you fill it a foot high in water, that's an acre foot in water. All right, in other words, a 1 acre foot is a volume of water sufficient to cover 1 acre of land to a depth of 1 foot. Okay, then to give us some, this one, 640 acres equals 1 square mile. So 640 acres equals 1 square mile. Do you think that's exact? Or do you think that's approximate? It's probably exact. No, that's exact. We're going to treat it as exact. And so, in 1 square mile, there'd be 640 acres. 1 mile is equal to 5,280 feet. Do you think that's exact or approximate? That's exact. So both of these we're going to treat as exact conversion factors. There's no uncertainty here. There's infinite big. So both of these would be definitions here. The principal lake in the California Water Project is Lake Oroville. Its water storage capacity is listed as 3.54 times 10 to the 6th acre feet. Or, this could be 3.54. What prefix would we use for 10 to the 6th? Mega. So this would be 3.54 mega acre feet. We could say that. We could say the same thing. Or we could say 3.54 billion acre feet. Because 10 to the 6th is million, 10 to the 9th is billion. And so 3.54 million acre feet. Express the volume of Lake Oroville in cubic feet. Cubic feet. So, this is like this dimensional analysis problem. I don't know exactly how I'm going to do this. We just start. And so this is example 75 here. And we start off with 3.54 times 10 to the 6th. So to 3 sig figs, we know it's 3.54 million acre feet. Acre times a foot. And then we want to figure this out in cubic feet. Cubic feet. So sometimes we have multiple units like this, and sometimes we want to leave one alone. So for example, feet, I don't want to touch that. I'd like to leave feet alone, but acre I'd like to change, because there are different ways to measure surface area or area. We could measure it in square feet, we could measure it in square meters, square inches, square centimeters. All those are okay for this. And so what we do is this is called our given. Our given is going to contain some degree of uncertainty. Is our given, do you think, exact? Is there exactly 3.54 million acre feet of water in Lake Oroville? No. Our given's going to have how many sig figs? 3 sig figs. So we automatically just take a look. Okay, there's 3 sig figs here. That's going to set how I'm going to set up the rest of the problem. If our given was exact, then I'd set it up a little differently. That is, figure out these things a little differently. Okay, so what we do is we start off with the given, 3.54 times 10 to the 6th acre feet of water. Sometimes we put this in, sometimes we don't have to put it in, because what we want is cubic feet of water. And since water doesn't change, I'm just going to leave it out, it's acre feet of water. And so in this case, it's not so critical that I put in the identity of this, what the volume is. Now, the next step is this. I got to get rid of acre or feet or both. And so I have a choice. I can get rid of acre. That's one path. Another path is I can get rid of feet. Another path is I can get rid of both acre and feet if I can relate that to something. Acre and feet. Well, the second path I don't want to get rid of because I want feet in my final answer. So it doesn't make sense to get rid of feet. Getting rid of acre feet combined means I need to know something about acre feet, but am I given any acre feet combined? No, so I can't get anywhere. This is going to be a dead end. But I do have something with acre. And I see that 640 acres is equivalent to 1 square mile. And so I see that just the acre term cancels out the acre term here. And so the units are still going to be a composite. It's still going to be weird because I'm going to have miles squared feet. And so if I were to stop here, this would be miles squared feet. This would be the volume of water if I took a square mile and raised it up by a foot. That would be a mile square foot. And how many mile square feet do I have? You know, is it part of it? Is it one or is it more? If I stopped here, but I don't want to stop here because that's not what they're asking. They're asking for cubic feet. But you know what? I know something. I know this. I know in 1 mile there are how many feet? 5,280 feet. But I have a problem here. Yeah, it's miles squared, not linear miles. This is miles squared. So how can I solve this problem? Well, to solve this problem, I need something with miles squared. But you know, I don't have it. And so do you know the easiest thing to do? Is if we square this. If we square this, then I'm going to put the 1 in here. Then if you know exponents, what you're going to do is you're going to square 5,280. You're going to square everything inside there. And so what we do is we're going to square this. We're going to square this. We're going to square the 1. And we're going to square the miles. We're going to square everything. And so what we end up with is this. This is going to be 5280 squared, feet squared, 1 squared, miles squared. Well, what is 5280 squared? And so let's figure that out here using the calculator. It's like close. What's that? Is this working now? 52. The Google calculator is not working. And unfortunately, I closed that other calculator. What was that other calculator? This calculator is fine. All right, so let's see, 5280 squared. 5280 squared. $27,878,400. And so this comes out to $27,878,400. Now, how many sig figs am I allowed? You know, this is fig squared over mile squared. How many sig figs am I allowed? 3? 5280, is that 3 sig figs? 4 sig figs? Well, it's ambiguous, right? Because if we have a 0 following, it could be 3 or it could be 4. Or it could be infinite. It'd be infinite if it were a definition. Is this a definition? Yeah, so it's infinite. And so we're allowed all these digits here. This wasn't rounded, so this would be exact too. But normally I wouldn't do it this way. You know, if I'm going to do, because there's too many numbers to punch here. So I probably wouldn't do it that way. I'll show you a different way. And so what's going to happen is this. The miles squared are going to cancel here. and that's going to leave me with square feet. Well, a square foot times a foot is going to give me a cubic foot. So this is going to be cubic feet. The way I punch this in the calculator is like this. I wouldn't do more than one sequence of operations. So I'd go 3.54. Obviously, numeral block doesn't work. 3.54. And then this one has an EXP key times 10 to the 6th plus 6. Let me make sure it worked, yeah. I just wanted to see if it worked or not because I'm not familiar with this calculator. Divided by 640 times, now times I just do 5280 squared. Because the order of operations of the calculator would do this, you know, it calculates each step and then it goes on to the next step, so I'll just do this. Which is this one, 27,878,000 equals this. And so we're going to write this all out. It's going to be 154 billion. It's going to be 154,202,400,000 cubic feet of water. And so 154 billion cubic feet of water. And so there are different ways we could write this. How many sig figs are we allowed here? 3. And so I would just round this to 154 times 10 to the 9th cubic feet. I wouldn't put it in proper scientific. In proper scientific notation, you want a number between 1 and 9 or 0.9 or something, 1 and 10. This, or you just call it 154 billion cubic feet. That's fine.
Why would you put it in scientific?
Well, I could put it like this: 1.54 times 10 to the what? 11. If I make this number smaller, I got to make this bigger, so it'd be 10 to 11 cubic feet. Because 10 to 11 doesn't register. You know, what registers means 10 to the 9, 10 to the 12, 10 to the 15. You know, that's everything. But it's okay. I mean, you could leave it like that. It doesn't matter. You wouldn't be wrong. Okay, you know, it's just talking about not registering, because you know, you're trained a certain way. Like when you think about currency, you know, when you think about currency, you think hundreds or whatever. You know, like I went to Japan and they talk about currency in units of 10,000. You know, 10,000. Now, how many 10,000s do you have? 2 of the $10,000 notes, 3 of the $10,000 notes. It gets confusing for me, because I can't do calculations quickly in my head. Because that's 10,000 would be 10 to the 5th, so I'm always converting it from 10 to the 5th to 10 to the 3rd or 10 to the 6th, and then I can come up with the number easily, you know, in my head. For the currency exchange. That's it. All right, let's continue on here. B, cubic meters. In cubic meters, what would this be? And so when we're given a sequence of problems like this, what we do is I don't take this answer here and then convert this into cubic meter. Because usually that leads to round off error. Well, what I normally do is I start back at the given. If you start at the given, then you aren't likely to round anything. Even though we might follow the same path, you know, for the most part. Let's start off here. And so why don't you help me out with this one? Where would we go from here? Yeah, we'll just to get rid of acres again. So do that. There's 640 acres in a square mile. Here, no, we don't square this, you know. The miles is squared, but acres, do we square acres? Because shouldn't both be squared? No, acres is already a unit of area. Miles are not. So we have to square miles in order to get area. But acres are already area. This happens in this, like a cubic centimeter is equivalent to, or defined as, we saw that earlier, 1 milliliter is equivalent to 1 cubic centimeter. This is cubed here, however, milliliters is not cubed. Well, you would never cube that because it's already a volume unit. Centimeters is not. Centimeters is a length unit, milliliters is a volume unit. This is why we have to cube this. Okay, so that gets rid of acres. Now where do we want to go? Hey, we're going to go to, well, I don't know too many for miles. You know, kilometers I might be able to go to, but why bother going to kilometers? Because kilometers is going to be an approximate. Do you know how many kilometers there are in a foot? I mean, in a mile? About 1.6, but that's not exact. In fact, if we look up the kilometers to miles, actually, let me go the other way, miles to kilometers. I said 1.6, but it's actually 1.609344. It's not an exact number, it's approximate, so we aren't going to use that. Whereas if we use this one, oops. If we use this one, then this is exact. This is the one to use here. And so we would go from 1 mile to 5280 feet, but we're going to have to square the whole thing, which means squaring every single thing inside of the parentheses. Okay, but from feet, where can we go? Well, I don't know feet to centimeters. Do you have feet to centimeters memorized? Yeah, I don't have feet to centimeters memorized. I would go, you know, what I would do is I'd do this. I'd go from feet to inches. I have that one memorized. How many inches? Is that exact or approximate? It's exact. So this one, I'm just going to square it. And so there are 12 inches in a foot, and there would be, well, what's 12 squared? 144. So there are going to be 144 square inches in a cubic foot. And so let's see, miles squared cancels, square feet cancels. Now I'm at square inches. So where do I want to go from here? Do I want to go square inches? Maybe I'm making a mistake here. I'm making a mistake here. Do you see my mistake? Because I'm getting rid of this one, but this one's still here. Do I want this one to go away also? Yeah, I need this one to go away also. And so I don't want 144 square inches. Do you know what I want? I have square feet here, and I have a foot. So foot times the square foot is equal to a cubic foot. And so what I have to do is, rather than square it, I have to cube it. Because I got to get rid of this foot here, which is square, and I have to get rid of this foot here. And so if I cube it, I can get rid of all these feet. And so that leaves me with cubic inches, but what's 12 cubed? 12 cubed is not 144. Let's see where my calculator went. Let's just do it. 12 cubed, 1728. So they're going to be 1728 cubic inches in a cubic foot. Okay, now where do I go? Centimeters. Centimeters would be the best place to go, because here I know one, and that is this. In 1 inch, there is exactly 2.54 centimeters. Except this is a linear inch. This is length. I want a volume, and so I'm going to have to do what to this? I'm going to have to cube the whole thing. And so 2.54 cubed is 16 point something, cubic centimeters in 1 cubic inch. That takes me to cubic centimeters, but I don't want cubic centimeters, I want cubic meters, which means I need one more, and that is this. Centimeters, I gotta get rid of that, and I know that there are 100 centimeters in a meter. And so what do I need to do to this? I have to cube it. And so 100 cubed, well, 100 is 10 squared. 10 squared cubed is 10 to the 6th. So in 1 cubic meter, there's 1 million cubic centimeters. Okay, now the units work out, because now I'm at cubic meters here. So if I'm a cubic meter, let's go ahead and do this here. Let me calculate. So first we do the dimensions, then we do the numbers. So doing the numbers, I got 3.54 times 10 to the positive 6 divided by 640. Times 5280 squared. Times 12 cubed. Times 2.54 cubed divided by 100 cubed equals how many sig figs am I allowed here? 3. And so what I want to do is I want to show 4 initially. I'm only allowed 1 round off step, so I'm going to show 4. I don't want to write all these digits out. And so let's see, this is 4.366. It would be 4.366 times 10 to the 9th cubic meters. Okay, so I show this. Now, note, I'm dropping the 5. Normally when I drop the 5, I round up. But I'm not rounding up, because that would set off a domino effect of rounding. And I don't want that domino effect. So I'm just going to drop the 5. Now I round. I'm only allowed 1 rounding step, and the true rounding step is dropping, not the 5, the true rounding step is dropping the 6. So this is going to come out to 4.37 times 10 to the 9th meters cubed. In other words, this is going to be 4.37 billion cubic meters. Which seems appropriate. I mean, it holds a lot of water, and so 4.37 billion cubic meters. Is that what you guys get? Did you punch it in your calculator? You getting the same? Some people, when they punch this in the calculator, they have so many keystrokes. It's like, but you don't always need that many keystrokes to do this. All right, now we're going to take this to US gallons. We're going to do US gallons. You're going to need, do you know any conversions from cubic feet to gallons or cubic inches to gallons or that kind of stuff? No? And so we're going to need some of that type of stuff. And so let's take a look if we can find some data at the back of the book. Usually you look at the front of the book, the back of the book, and then within a chapter. And so I'm going to go back to the back of this book, and I'm going to go to page E5, to N5. I'll look at my volumes. Okay, when we look at the volume relationships here, we can use. Let's take a look at that. All right, liters to milliliters, is that exact? Yeah. Milliliters to cubic centimeters, exact? This is something we might be able to use. Cubic centimeters to milliliters. Liters to quarts, is that exact? No. No, we want to do this one here, but maybe we have to. Here, gallons to liters. Can we use that? Yeah, we can use that, but is this exact? No. So if we're given 3 sig figs here, then how many sig figs, if we use this one, how many sig figs should we use it to? We should try to shoot for 3 would be absolute minimum, but we should try to shoot for 4 to minimize ground off there. Well, anyway, why don't you give it a shot? Here. He grabs him. Can you do this on the index card? I just want to see where people are at. Yeah. You can work with your neighbors or friends on this.
not